So HHK, we're working with electrification and we're working with energy efficiency to create sustainable products for the companies that are members in HHK. And it's everything from huge industry groups like Hiab and Voith to smaller SMEs like Sumfab, Oilquick. But what we're doing is energy efficiency. And Delsbo Electric is also about energy efficiency and sustainability. And what we want to prove with Delsbo Electric, for me at least, the most important thing is to prove that you can do anything from any place in the world. And that's also how we operate in Hudiksvall. All of these companies, it's a small town, but we're exporting all over the world. So our products have a huge impact. And Delsbo Electric can also have a huge impact. And we're kind of turning Delsbo Electric into a platform for discussions about energy efficiency, sustainability, something much larger than just a competition about an energy efficient vehicle. So that's what we're moving into, and this is the first proof of that. So thank you.
And together we have been working on many different aspects of the energy system perspective with the hydraulic cluster, and many different partners across our region and internationally, of course. My name is Anna Douglas. I am chairing this panel. I'm really delighted to be asked to do it. I am a strategist working for the Region of Gävleborg, which is a regional authority in Sweden. We are a very small region in terms of people, but a big region in terms of area. I did the calculations and we are 16 people per square kilometer in this region. It's very sparsely populated. We have 8 of our region covered in forest. We have a fantastic industry base in steel and forest and paper and pulp industries. The most innovative town in the world in Sandviken, where Carlos works and I live, in terms of the number of patents. We have a lot of innovative, creative people. And we believe together that we can actually create a more sustainable future. This is about the climate emergency. This is about having a good quality of life. And this panel we wanted to set in that context because this isn't about nuts and bolts and technical solutions for the sake of it. This is about a transformative technology that we believe can actually contribute to that good life that we and others can benefit from. In Gävleborg, we have great conditions for that innovation to grow. We need the collaboration between all of you in this panel. These are systems transformations that we're talking about that cannot happen by one single actor alone. And from the region, we want to create those conditions where we can collaborate, innovate, create the new industry, because we're a region in industrial transition. We need to change, we need to have energy efficiency, we need to have that coming across to our transport sector, mobility solutions, industrial solutions, and the whole energy system. So we have a panel called What Works with What, looking at hydrogen from this energy perspective. This is about society. How we can actually understand what this offers, what it means for us, and what we can all collaborate to achieve. So we have a fantastic panel. I want to introduce them one by one, and then we will hear a pitch from each person. That can be, it's up to them how they formed it, but we haven't got a lot of time, and we have so many interesting people on this panel. I'm going to start by introducing Åsa Bye. She works for PowerCell as a business manager. They are a fuel cell developer and manufacturer, and she has lots of experience from different sectors, including the energy industry and also in regional development, which I didn't know before. Åsa, thank you. And yeah, she also worked for the trade association Hydrogen Sweden, so she has a really excellent background for this panel. We also have Carlos. Now, Carlos, help me with your second name. Bernay Lopez.
Bernouy Lopez.
Okay, knew I would get it wrong. Senior engineer at Sandvik Materials Technology. Before joining Sandvik, I think about 3 years ago, Carlos, you were working in academia researching fuel cell materials.
Yes.
Thanks. And we have Marcus Rösth. There you are, Marcus. You're a senior R&D engineer, or manager, sorry, for control systems at Hiab, sitting in Hudiksvall. We have Pontus Svens. Where are you, Pontus? There you are. You're the senior research engineer at Scania, researching batteries and fuel cells within the Scania sector. We have Petter Krus, who is professor of fluid and mechatronic systems at Linköping University. And last but not least, we have Antti Vainio. You're the business policy advisor for the Central Swedish Chamber of Commerce. So we've got a fantastic panel. We're supported by Paul, who will be monitoring the chat and keeping everyone undisturbed by muting people who forget the house rules. But please make sure that your camera and your microphone are off unless you're speaking. It helps just with background noise. But if anything happens, use the chat and contact us if you have any questions or issues during the course of this panel. We are recording this as well so that we can share it to a wider audience later on. So let's start by hearing from Åsa. PowerCell, tell us about what's happening in your world.
Yes, thank you, Anna. And please let me share a picture with you that I hope can help a little bit. Here we go. Can you all see it?
Yes.
Because what I want to share with you all is that what we at PowerCell feel is we have hope for everything that is happening around the world right now regarding hydrogen and fuel cells and the development of that. It is going very, very fast. Hydrogen discussions are scaling up, and so will fuel cell industry as well. PowerCell is a company that is, well, it has been on the market since 25 years ago, a spin out from Volvo, and was put on the stock exchange in 2014. And we have been developing and now manufacturing fuel cells and fuel cell systems. Mainly since we are from the automotive industry. Of course, automotive is one of the core businesses that we have worked with, but now moving into the marine as well as the stationary applications, hence following the hydrogen production, trying to be there where you need electricity and when you need electricity, because that is the beauty of the fuel cell systems, that you can move the energy stored in hydrogen to where you want it and then put the fuel cell where you need that, and then use the fuel cell systems for electrifying what you would need. It is a proven technology. We do have the fuel cell systems up in the air. ZeroAvia was the project that was revealed last week. We are putting it in buildings. We are right now building megawatt systems for boats, has also been revealed a couple of months ago. And what we can say about that is that there is a lot of achievements that are out there that we can share and we can talk about, and we can also see that what can be done with it and how can we scale up the fuel cell industry as well to make the shift happen. But we can't do it alone. And very much of the PowerCell story is about engaging together, co-create together with the business of hydrogen, but not at least the industry within steel or within ports, airports, or where you would like to have more electricity and also heat, because that is something that especially for the northern part of the world might be a viable solution, a viable energy source that we can utilize as well. So the co-creation is a need, just like you said, Anna. But that gives us hope because there's a lot of activity happening right now all over the world, and we are happy to be a part of it. So let's say Planet A, that is what we are talking about every day at PowerCell.
Excellent. I like the Save Planet A because there's a lot of Planet B talk, but we have only Planet A. So
For sure.
Important. And, you know, I go home and speak to my family about what I've done in the day, and it is my daughter who I look at and I think we have to do something. And this seems like too much of a great opportunity to let this slip by, especially in Sweden. So thank you for co-creation is and hope.
Yes.
Is what I take. Excellent. So our next panelist, I have Carlos on my list as my next speaker. Carlos, tell us about your world and what's happening with Sandvik Materials technology in this space.
So I have a few slides to show with you. So first of all, thanks a lot to invite me to this panel. This is very exciting to talk about what we do and what I see a future in hydrogen for the society. So a little bit about me, I'd like to start. I consider myself a scientist in fuel cells. As you have seen from my accent, I'm from Spain. I did a PhD in high temperature fuel cells in Liverpool, but I've been moving a lot during the last 15 years in many countries across Europe and also in Japan. And why it's important hydrogen to me? I mean, this is one of the questions that Anna challenged us to answer when she was organizing this panel. Well, green hydrogen is a great tool for enlarge the use of renewables, and we cannot get rid of this fantastic tool to fight climate change. And as Anna said, I joined the company 3 years ago. To bring the knowledge in fuel cells. So what Sandvik does in fuel cells? Well, we help to build this. We help to build fuel cell cars. So one of the things that we have is we produce coated materials. We produce these large coils that you can see here with very thin coatings in very large volumes. So how thin? So very thin, less than 1 micron, and with a nanometer precision. So that's a high-tech product. And what is this for? Well, this is actually to build what we call the fuel cell stack, what it will bring energy, right, to the application. So I just put here that we have a great opportunity in Sweden with all the Swedish already value chain that we have. You know, our material can be formed into bipolar plates. That is what you need to put later in the fuel cell stack to make the car to work. So, and here, Pontus, you should excuse me. You should have put a Scania truck here to make it even rounded on the Swedish value chain. So one important thing that Sandvik has been involved is in the construction of the infrastructure for the hydrogen utilization. It is one of the things that we are going to see the more focus in the coming years. We need hydrogen stations. We need to produce hydrogen. So I don't know if you know, some people still don't know that in Sandviken we have one of the few hydrogen stations in Sweden, and Sandvik was involved in this. More in concrete, my colleague Mats W. Lumber, who is a fanatic also of hydrogen. So to finish, what else needs to be done and by whom? I think we need to bring the technology out there and show that works. I mean, this is what we need to do. I mean, we need to show that mass manufacturing is possible, it's already there. We need to deploy our systems to make the technology cheaper and visible to everyone. I also, as a scientist as I am, need to highlight the importance of the continuous R&D support. So this means money, of course, to help the scientists, to help us scientists to find better and cheaper solutions with this continuous loop of deployment, see what is going, and then going back and develop better materials. And who is involved? I think everyone, from citizens to politicians to industries to universities. I see everyone involved on this loop. So so that's it. So I'm very excited to participate on this. So I can give the word to you, Anna. Yes.
Thank you, Carlos. Really good. And I have to put in a plug for myself in in that launch of the hydrogen filling station in Sandviken. There's a really excellent film that features, amongst many other people, me, because I was there when the ribbon was cut on this very exciting project alongside your boss and Mats Lundberg. So I recommend, if anyone does want to come and visit the hydrogen filling station, they can, in the first instance, contact me, or I don't know if Anders Lundell is also on this call in Sandvikens kommun. He can help arrange a visit so that you can actually touch and feel what that technology actually looks like, and even try out filling a car. And a group from HHK came down a couple of weeks ago to do just that. So speak to them as well if you want to find out more. Thank you. Okay, so I take from that one Swedish value chain as a highlight in what you said, Carlos, and I think that's really important that we keep that going through this panel. Marcus Rösth from Hiab, tell us about the world in control systems and everything that Hiab is involved with.
Yes, okay. First of all, I mean, Hiab belongs to a bigger corporation called Cargotec, where we have basically 3 other sister brands with Kalmar and MacGregor. So Cargotec is basically a material handling equipment company. So we work in different contexts with the sea, with MacGregor, terminal, with the Kalmar, and on road with Hiab, where I belong then. As a company, I would say that we have been focusing quite extensively on digitalization, automation lately, and that has been the main buzzwords. But I see a clear trend in the company that we go more sustainability, and where the buzzword electrification, not electrification, but automation and digitalization previously were very common. Now we see sustainability, and that's really nice to be able to work for a company that's really been awakening that much. And we're committed also to, I mean, the 1.5 degree target as a company, and we have been doing analyzing the footprint from a CO2 perspective quite extensively the last year. To build up a base ground to actually start doing some actions, and where we are at the moment is that we have set the target, and the target is that we should reduce the CO2 footprint with 50%, and that is quite a challenging task, I would say, considering that less than half is actually from the usage also, and a lot of comes from purchased goods like steel. So hydrogen from our perspective, I think it is both interesting from a usage part, of course, but then again working with suppliers who is really supplying us with goods, and making sure that the complete life cycle is sustainable. There I think actually hydrogen could be of great importance. You know, we saw when we visited you, Anna, and actually met with Mats Lundberg in Sandviken, and met
Göran
Nystrand from Ovako, and see how they actually been deploying it. It's really inspiring. We also have contact, of course, with SSAB, which is one of our suppliers on steel. Our sister company have been working with them on hydrogen as well, where we have been we made a demonstrator on the hydrogen forklift. But here as a company, we normally sit on the power source. The power source is normally coming from the trucks, like in Scania or Volvo or Mercedes. And so we definitely need to follow and understand how that would affect us. Hydrogen cell powering our equipment, or I'm not sure if that's going to be feasible. We are really investing quite heavily in electrification at the moment. That is our main target at the moment, but we need to be open for other sources as well, as long as when they develop. Another thing which I think is important as well as for us as a company is to understand the hydrogen business, because it's also, as I see, a business opportunity in that business, especially now with the growth in Europe and the large amount of sum actually putting into to enable the infrastructure. We are already doing such, looking at opportunity when it comes to sustainable energy. We're making special cranes for wind power mills. We just showcased a new special crane for mobile charging stations, like big batteries that you move around with a company Jolt. So also from that perspective, I think the hydrogen business could be of certain interest for us.
Thank you. Interesting. The diversity of points of connection that you have is fascinating, actually, from the whole supply chain down to potential customer segments.
I think also that is one of the challenges, to actually understand the complete picture, and I'm not even close to scratch the surface at the moment, and that's why I think it's very interesting to be here.
Yeah, really interesting, because I mean the discussion I had in my previous Zoom meeting today was actually about this multi-level innovation that we need to get into, that we need to be able to work with systems innovation at the same time as we're working on product. Sig, yeah, I need you to mute, please. Yeah, so we need to get into this multi-level way of working so that we can get the right level of innovation within this complexity. If you understand what I mean, we need the whole energy system up here at the same time as we're having product and service development in individual companies, which is quite a complex transformation. Thank you so much, Marcus. Pontus and Scania, researching batteries and fuel cells. Tell us about where you're at.
Thank you very much, Anna. Can you hear me now? Yeah.
Yes.
Good.
Loud.
So yeah, I have a presentation, a short presentation. I can start by just presenting myself. I've been working with electrification in Scania since 2007, starting with hybrids at that time, and I've been focusing on batteries from that time. Also, I've done my PhD within battery aging, and the last maybe 3 to 4 years, I also have worked more on system analysis on fuel cells for heavy-duty vehicles. And I'm also affiliated 1 day per week to Royal Institute of Technology, KTH, within applied electrochemistry. So I have some connection to research on both fuel cells and batteries. But today I will focus on some challenges with fuel cell electrical vehicles. So let's see if I can share my screen here.
That's it.
You can see?
Yeah.
Perfect. So here we can see 2 demonstration projects that we have today with 2 customers. The left one, the yellow garbage collection truck, is a project in Gothenburg with the company Renova. And the right one is in Norway with the company ASKO. So in both cases, Scania is a provider of the battery electric part, I would say, of the truck, and then bodybuilders are putting on the fuel cell and hydrogen storage. But we try to learn from those projects, and we will be involved in collecting data when they are using it. And the yellow one, then actually PowerCell is the provider of the fuel cell system. So this is what we have ongoing now, and this Renova project is also part of a bigger EU project. It's quite interesting. This is on so to say, truck level or vehicle level. Then we have also some research projects. I will not go into detail on that. Next slide here. The key questions. We have some key questions on hydrogen. I tried to put down some bullet points here. Of course, you will, when you look at electrification, if you look at completely zero tailpipe emission vehicles, I would say there are two technologies that are actually working today for heavy duty vehicles, and that is complete battery electric vehicles and also fuel cell electrical vehicles. Then you have a lot of different hybrids and so on, but they are often not complete zero tailpipe emission vehicles. So this is the two, I would say, the two technologies that we see as future for this kind of electrified vehicles. And fuel cells and hydrogen, of course, you need to have a very environmental friendly production of the hydrogen to be, if you look at the well-to-wheel CO2 emissions, for example, to have very low impact there, and also to have a good cost of ownership for the users of the trucks. You need also have a very low price. So this is, I would say, a challenge from the hydrogen point of view, and also looking at the hydrogen refilling stations, standardization for heavy duty vehicles. Should we have gaseous hydrogen, liquid hydrogen, cryo-compressed hydrogen? What pressures would be viable for gaseous hydrogen in that case? This is, I would say, also a key question that needs to be sorted out here in the future. Also, the availability of the hydrogen refilling station. Where will they be placed? I have some example on the right there. I just tried to see what kind of projects regarding hydrogen refilling station for heavy duty vehicles are ongoing in Europe today. There are quite a lot, but to be more commercial available, I think more work needs to be done regarding the availability of the hydrogen refilling stations. And also one really important thing, I think, to be able to have fuel cell electric vehicles as a complement to battery electric vehicles, I believe the refilling time is one of the benefits for fuel cell electrical vehicles in the heavy duty segment. So you need to be at least in parity with the conventional fuels we have today, I would say. So this is what I see today for very important questions regarding the hydrogen distribution and production. And then if we look into the vehicle and the fuel cells and hydrogen tanks, some questions there. If you look on the right, I just did a small sensitivity example of setting some 20-30 cost on different components.
Thank you.
Thank you. And you can see that fuel cell system efficiency and of course the hydrogen price is really affecting, in this case, the transport cost or the cost per ton kilometers. So fuel cell system efficiency, and then I'm talking on the complete system with everything around the fuel cell stack. This is really important for us as a company to understand and how to maximize. And this is quite similar to what we are doing today already at the combustion engine. we need to have really, really high system efficiency to be competitive. And then we have the power density. Of course, you need to minimize the installation volume of everything to be able to maximize the space for the hydrogen tanks, I would say, in a fuel cell electric vehicles. So this is really, really important. And then fuel cell cost, of course, if you have a lower cost on the fuel cell system, then you could actually install a larger system, and then you can work it at maybe a lower load to get the higher efficiency of the system, and then you get the better TCO. So this is connected. And also, of course, you need to have sufficient lifetime. Maybe you can afford one rework of the system within the lifetime of the truck or something like that, to be cost efficient. And then you go to the tanks. You see that the tank cost is not affecting the total business case as much as fuel cell efficiency. But of course, you need to take down that cost as much as possible without affecting the safety, because this is a really critical part, I would say, to have really safe pressure vessels for the hydrogen, either if it's gaseous or liquid or whatever. And then if you look at this case where we have done our calculations on a hybrid solution, with that I mean it's a small battery, so the fuel cell is providing the average power, and the battery is just shaving up off the peaks, power peaks. Then you can see that the battery cost, even if we have used a very expensive, in this example we have used a very expensive power optimized battery, it will not affect the total business case very much. So this is what we have identified as key questions that we need to address from our point of view, from the vehicle manufacturer point of view. This is what I wanted to
Thank you.
into this discussion.
It's a very interesting and important list of key considerations. Just a quick question for clarity. Some of those questions I guess are mostly at the European level in terms of standardization work, etc.
Yeah, I would say so.
Yeah.
Or maybe on a global level even. Yeah.
Okay. Good. Thank you very much. Interesting to see the relative importance as well in terms of your assessment.
I think it's important to understand that.
Yeah, and the extreme importance of the hydrogen or green hydrogen price. And just for clarity, when we are talking in our context here in the region of Gävleborg, we are talking about certified green hydrogen. This is not, we are not in the space of grey or blue hydrogen in our discussions at this point. Of course, that is going to be part of the European and global markets for some time to come, but it's not on our agenda. Our target picture is 100% green. Just so that the other people in the audience also understand our context. And in Sandviken, we do have certified, the world's first certified green hydrogen, in fact, that AGA, which is now Lind Gas Group, produce with power provided by a wind farm. So that drives the production hydrogen that is already used within the Sandvik plant. Thank you very much, Pontus. Great to hear what's happening at Scania. Petter, Linköping University, tell me how it is at your end with all of the interesting things that you're involved in. Petter Krus, are you there? Christopher, I can see you.
Okay.
Now we see you, Petter.
Oh, we didn't see me before.
No, I did.
Okay.
Now we see you.
Yeah. So, do you see my presentation now?
Yep.
Yeah. Okay. So I would like to take a more overview. First of all, I'm from the Division of Fluid and Mechatronic System at Linköping University. And our research is primarily in fluid power hydraulics, particularly in mobile applications. And we work with HHK in this field. And of course, electrification is very high on the agenda here. How do we adopt fluid power systems for electrified systems? We also have quite a lot of activity in aircraft system design because we are in the Linköping, which is the aviation city of Sweden, with Saab here. And if there is some noise in the background, that's Britain. Okay.
It was perfectly timed noise.
So we have developed a framework for. I'm most interested in on a top view. How do you select technologies? And we can have a framework where we look at. We have a requirement space for a technology, and then we have what the technology can do. And you can say we have a technology comfort zone where the technology can readily be applied. If you want to change the performance, it doesn't affect other aspects of the design. And then we can have technology critical, where everything is about the technology. If we want to increase range, for instance, it will dramatically impact everything else. So there, the development of technology really becomes critical. And this is how we can look at that for different vehicles, for instance. Very important is to look at this specific powers and specific energies. And I think people don't realize this enough. I just want to show the impact of power density on aircraft. In 1932, this was the world's fastest aircraft. It had a top speed of 476 kilometers an hour. 50% of its empty weight was engine. Saab 2000 has similar max speed, a little bit higher in fact, but only 5% of its empty weight is engines. So this is really important, especially for things like aircraft. And we have you can see here the different, we have truck diesel, petrol engine, turboshaft engine, electric motors. They vary a lot, and we have fuel cells there. And this is really critical for fuel cells. Of course, you've seen this before between batteries and diesel or kerosene, the specific energies. With hydrogen pressure storage, which I think is the lowest hanging fruit when we want to deploy it, it's the hydrogen is only about 10% of the storage system weight. So it's somewhere between batteries and diesel in total. When it comes to efficiencies, we can say that fuel cell plus electric motors are comparable to a combustion engine, and that is particularly important in aircraft. When it comes to electric tracks, we can say that, well, cars, for one thing, is battery technology in cars is rapidly moving into the technology comfort zone. We see the penetration of pure electric cars is growing rapidly, and it's primarily driven by cost. When it comes to tracks, we can see the batteries can be used for short and medium range, and probably within technology comfort zone there as well. However, for long haul, we need to have to fulfill that. We would need, for a 40-ton track, we would need like 10% of that would be batteries, so 4 tons. That would be really technology sensitive, but there are also other aspects around that would make it a challenge, like charging stations with very high power and also very large batteries with some fire hazard. I think, however, this will be worked on, the last one there. But this, I think, is a very good application of fuel cells, because you see the power density of fuel cells is comparable to the combustion engine. So energy hydrogen storage would be somewhere in between for a battery and for a diesel. And then, of course, we have the competition from electric roads to some extent. But I think this is a good example. An even better example, I think, is construction machines. You could maybe use batteries for a whole workday, but then the construction sites are often without a charging infrastructure. So here, fuel cells would be very appropriate. When it comes to aircraft, we see that Airbus has really shown a roadmap now for hydrogen aircraft, at least for medium and short range and medium range. For very long range, we probably will look at synthetic fuels or biofuel in the future. The thing is here, however, that you have to what Airbus sees is that you burn the hydrogen directly in the engines, because the efficiency will be reasonably the same, and the power density is so much higher in a gas turbine engine than it would be in a fuel cell. For aircraft, I think battery is hardly relevant. I mean, if an optimistic theoretical range would be like 560 kilometers with 50% of the takeoff weighted batteries. We are looking at the BG, but with batteries. Then we have to add loitering 45 minutes extra, and we should be able to reach an alternative airport. So this severely restricts the operations in quite a long future. And from a CO2 point of view, the number of flights that could be replaced with a battery would be totally irrelevant. It's a long haul that really have an impact. So this would be really technologically critical / impossible. So for aircraft, I think fuel cells have a low power density, but it could be useful. So it could be useful only for slow aircraft. However, if we can increase the power density a few times, it would be much more interesting. And they have to compete head-on with hydrogen burning aircraft with comparable efficiency. However, there can probably be business case built on other secondary aspects, for instance, much lower maintenance, etc. Okay.
Thank you very much. I'm just thinking of the word flexibility here in terms of the hydrogen, you know, the fact that we can have the same production going to fuel replacement versus supply into a fuel cell. The direct combustion of hydrogen is also extremely relevant for the industrial sector and as a feedstock. So you mentioned also synthetic fuels, e-fuels. There is a lot of opportunity for that supply chain within our area associated with the pulp and paper industry as well. And that's been identified by the Research Institutes of Sweden, RISE, as an opportunity for growth. Again, fits well with the supply chain that we have in terms of logistics to supply commercial aviation from Gävleborg via the link to Arlanda. Excellent, thank you, Petter. And now going last but not least at all to Antti at the Chamber of Commerce. Antti and I have many crossing paths, but Antti, tell us how this is relevant to your focus and your members.
All right, thank you. And I just want to say it's fantastic to be here, because I think it's so great what Delsbo Electric is doing. And I think it's such a joy that you guys are able to pull through the Delsbo Electric even this year. And I think this is a great opportunity to use this kind of digital form as well to build on it and to have this dialogue. So big thanks to all of you who've made this possible. Yeah, I'm the head of public affairs at the Central Sweden Chamber of Commerce. So we're the Chamber of Commerce for Gävleborg and Dalarna. And before I started here, I was the policy advisor for the Minister of Infrastructure at the Swedish government. So my background is not in the technical aspects of all of this, but rather in the policy side of it. And that's very much what I work with at the moment as well. And the way we see it is that we're a really strong industrial region. We have an industry that goes back hundreds of years that still is really strong and relevant. That's becoming really high tech and top modern. We have also an industry that has sustainability as its unique selling point. We can see that the forest industry is really becoming more and more relevant in terms of the bioeconomy and all the implications of replacing unsustainable plastic materials with renewable materials from the forest. And that's really becoming the unique selling point for that part of the region. But we also have a steel industry that already today is really clean. We have steel manufacturers in our region with 80% smaller carbon footprint than their global concurrents and competitors. Sorry. And that's really something that's becoming more and more important, because we can see that the demand for this kind of sustainable solutions is increasing globally. And if we have the possibility of going in the forefront, turning this even more into our selling point, we can build an even stronger industry in this region. And talking about steel industry, that's when hydrogen comes in a most obvious way. We are all we all know about the hybrid project and the possibilities of using hydrogen to cut the last carbon emissions from the steel industry. With the hybrid project, we can cut 10% of Sweden's emissions by moving into fossil-free steel manufacturing. And that's going to be really important to us going forward and making sure that we remain a relevant industrial nation. So from that perspective, our organization has I think we have an important role in facilitating a dialogue between the industry, between the companies and politicians. That's one of the things that we're building on. We have a responsibility of informing the politicians of what our industry means, not only to the industrial companies, but to this region, to employment, but also to making the green what's it called, going towards a fossil-free economy globally. In terms of hydrogen, just last week we arranged a high-level meeting between the governors and the regional leadership and some of our steel companies to kind of raise awareness of the issue of hydrogen and to tell them that Sweden has to step up on the European level. Because look at what the European Union is doing in terms of the hydrogen strategy, in terms of the huge investments that we see. Sweden needs to step up there. We need to make sure that we are part of that process. And then in our region, we have to look into what makes us unique. And I think it's great what Anna, you all are doing at the region and with the hydrogen valleys and all of that, and to really inform all the decision makers about the possibilities that we have here, about the history of using hydrogen within the steel industry, about the knowledge we have and all of that. So I think that's one of our main parts there really is to push this agenda on a political level, both within the region but also nationally and within the EU. Just one last thing about what we're also doing is that we have also very heavy industries that are really dependent on transports. We need to get the goods out of here to the whole world. And that's one of our focus areas. And we see that while we've been talking a lot in the past about costs for transports, what's increasingly important as well is the sustainability aspects of it. And companies like Sandvik and all the others are increasingly demanding to know what kind of impacts their transports have. And here we, together with Sandvik, Holmen, SSAB, and all the major industries are looking into creating a roadmap for sustainable transports for our industries to facilitate more fossil-free transports, but also to make sure that our industry has a good competitive advantage. And here we have the interesting example of world's first electric road on a public road outside of Sandviken, where lots of the industries were very heavily involved together with Scania, for example. And I think that's what we can build on, but look into different aspects of it. How can we use the railway system more effectively? How can we move the goods to the sea more effectively? And how do we use biofuels, electric roads, battery electric vehicles, and fuel cells more effectively in the system? What works with what, like your very good title for this meeting is, to make that kind of roadmap. And I think that's where Scania also can come in to look into, like, how can we hurry up creating this demand for hydrogen filling stations? How can we make sure that the demand and supply go hand in hand? And how can we together through collaborations make sure that we don't just get stuck on the same pilot phase where we got stuck with the electric road, but instead accelerate the process, go towards full-scale implementation as fast as possible, because that's what we all want to do and all have to do.
Thank you, Antti. Excellent input, and great to zoom back out again into the big picture about what this is for our region. We of course have gone over in time. As time optimists we only have 5 minutes left of this call, so if anyone has can we discuss, I'm just reading a comment here, can we discuss the possibilities of hydrogen? Oh, that one disappeared, sorry. Åsa, did you want to ask a question? You're muted.
Yes, here. Now, a reflection, because thanks everyone for great presentations and great questions put up here. Being a representative of a fuel cell company, I can see that, just like I started with, hydrogen needs to come first. And Sweden has great possibilities, not only within hybrid to produce green hydrogen, but when we talk about hydrogen and fuel cells, we often talk about the transport mode. If we would look into the possibilities of hydrogen to actually charge the charging stations, to peak shaving, to actually save the possibilities of the nets, electrical nets and network we have, what we can do with hydrogen and fuel cells actually for civil security, powering up the electricity where we need it, when we need it, then hydrogen is a great asset for that. We very often get stuck into either it is battery, and that is smart in some transport modes, or fuel cells in other transport modes, and that is correct. But if we look at the possibilities of hydrogen being the enabler for more battery electric transportation, for instance, or when we talk about digitalization and electrification of smart cities, I honestly meet people believing that there is no problem at all when we talk about electrification, because every data bit will be in the cloud. Well, what is actually supporting the cloud? That is electricity, and how to power that up. So I think that education is also a part of this that we need to look into. A lot more of education down to the basis of what people are living in every day. That is something that I'd like to elaborate just shortly around. Any comments on that?
Excellent point. Carlos, you look like you were leaning forward.
No, I completely agree. I think this is what we need to focus, and we need to kind of show how this it's actually happening. And there is also a quite relevant question in the chat about the possibilities of sector coupling. I mean, we are not here talking about hydrogen or batteries or wind solar or I mean windmills or solar panels. No, we're talking about enlarge the possibilities of the use of the renewables. And that's where the hydrogen comes from, and that's where we need to kind of show what hydrogen is helping here. So,
exactly. So if we're looking at it from, we need to increase the supply of electricity because everything is being electrified. There is an increasing demand for electrical effect, and how we get there it's a beautiful dance between power from batteries and power from fuel cells, and how those interact. I usually describe it as kind of like this, you know, that they fit together in various different ways, in various different forms, and it shouldn't be seen as one or the other. It has to be, you know, bridging the gaps using the flexibility of hydrogen to fit those spaces in between. And we need to think differently, as you say, Åsa, that, you know, this is a incredibly versatile energy carrier. We need to think about where it can fit instead of choosing winners. And we've seen, for example, the electric road test bed outside Sandviken. How can we think differently about that whole way of working, that whole way of thinking about shipping goods from inland to the world, which we need to think in a whole different way and collaborate in a different way in order to understand the possibilities that this technology could offer. It needs transformation, which is a bit scary for some people. And I liked your diagram, Petter, about, you know, are we in our safe zone where we know exactly where we are and we control all of the angles, or do we want to stretch ourselves? Well, here I think we have a perfect opportunity to do that stretch and see what possibilities we have. Our time is officially out. Is there anyone else who has a extremely important question or last word?
Since there are some fuel cell experts here, I'm very curious to what you see of the possible power densities that are achievable today and in the future. And we are looking at the system level with all the auxiliary systems needed for a fuel cell.
Petter, I would like to answer you quickly. We haven't achieved exactly what we want yet, but it is ongoing. I advise you to contact our CTO, Thomas Tingelöf at PowerCell. He has some really hairy goals. We are working on it, and I cannot really reveal very much sitting here right now. But please take contact with Thomas Tingelöf at PowerCell, and you can see something that is state of the art right now.
Okay.
Exciting.
And I would say, Peter, that what you say in your comment here in the chat, it's exactly what you need. You need to take the best of the both worlds together. But we are facing the issue that we are maybe working still with quite expensive technologies, put them together, competing with a very cheap technology, you know, and kind of also losing the objective that it's climate change fight. So we need to kind of come to this overall picture to see that we need to do compromises, that we need to maybe take things step by steps. But I see the hybrid systems as the solutions in the future. Maybe not in 3-5 years, of course, because it needs to be a lot of things done. At least what I'm researching, materials. We need cheaper materials to put a battery and a fuel cell together, I would say, in a sufficient power, you know, to make it competitive.
Yeah, my point was to emphasize that it's not either or. It's not battery.
Exactly. Yeah.
I need to raise one question if I maybe drop something here. In order to make the hydrogen business going, really be sustainable, you need to have sustainable energy to be able to make the kind of the green and not stick with the blue or the gray. And looking at the European level of renewable energy at the moment, I mean, look, a country like Germany are at best 10 times higher than us on the CO2 equivalent when it comes to generating energy. So if we're gonna go in Europe towards the sustainability. They need to massively invest in their infrastructure when it comes to generating electricity. So without that one, how are we going to then technically within the European Union, Sweden is the only one that could have the capability of generating and making green. You're saying no now.
I'm saying no to that. What is happening right now in Norway is actually immense on this.
Yeah, but Norway is not in the European Union, right?
Well, for sure. I regard them as Nordic.
No. I mean, France is sometimes they are very low on the CO footprint equivalent, but they can at best then generate the blue one, which is from nuclear power, but not the green one. So I mean that is one question I have. How are we going to do that and still make it?
But I think this comes again down to the flexibility of hydrogen as an energy carrier to take off the peaks from the production capacity for intermittent renewables. Where you have the intermittency, there is constraints on the grid, where in most countries like outside Scandinavia, where there isn't, actually outside Sweden, where we don't have such a strong grid. You look at the case of my home country of Scotland, where that is an absolute classic. And as Carlos said, this is about enabling increased penetration of renewables, but making sure that we take the value of that into the energy system instead of just into the grid.
To see hydrogen as an enabler for going to sustainable energy production within Europe, that I can see. But that then by itself it would.
Yeah, of course, and I think this is one of the points. I mean, we need to also see the hydrogen as a great opportunity for the decentralization of the energy generation. I mean, we need to get rid of this consumption that we have of big power plants producing energy, and from then, we distribute energy to the different points. We imagine now like Norway, a big oil and gas country who is giving power to the rest. No, I mean, hydrogen, what it has is the possibility to do small things where it's needed, smartly connected to the other technologies for the application that is needed. And it's not going to be sufficient by its own, but it's an important part to make the other ones to work and to make them cheaper also, because you would need smaller systems, you would need it would be faster to do it. It has all these arguments for.
I think that is about our thinking. We need to step outside of our current system to understand what the possibility is with this different system. This is a whole different way of thinking and working. The benefits that it could have in terms of resilience, in terms of, if we have climate impact, what can that actually achieve for our society in terms of our resilience? If you take away our dependence on very inefficient transmission and distribution grids, what effect or productivity could we get from that energy that we already have in our system? It's completely mind-blowing. The UK grid is a 30% efficient system. It's pathetic. We need to look at it from an overall energy system level and then start looking at different applications of how they can interact at the system, and that's what sector coupling is about.
I have 2 comments that I just like to bring up, if it's okay. It's about maps. We have Dagmar. I think Dagmar is in Hong Kong, and she was asking for an image where you could show how the different sectors need to interact. And I guess that's something that Antti spoke about. I guess that is in the drawing, and each business has its own. So I think there is not a granular map enough that can show everything. I think what Dagmar is looking for is the gaps between the different sectors, because that is fertile ground for innovation. And the second map-related question was from Sigurd, not Hong Kong, but Hudiksvall. And he's talking about the hydrogen gas pipe network that we have in Europe that is huge. That has a lot of overcapacity, as far as I understand, even. We don't have that in Sweden. So how do we need to do it differently?
That's where the decentralization comes from.
Yes.
That's where you need to come out of the traditional picture. And it's where Sweden has a lot of renewable electricity generation capacity to do it. Yeah.
As a matter of fact, when I talk about using hydrogen and fuel cells, that can be, just like you say, Carlos, very local. Very often they are put in place to be off-grid, the fuel cell systems to be off-grid. But very often I also say why, because the electricity in Sweden is cheap. It is usually produced green. And even if you are in the southern part of Sweden, then having to pay quite a lot of money, sometimes the price of electricity is so low that you actually can use it to make hydrogen to a day when you need hydrogen and electricity produced at your own site. So you can, as a matter of fact, use hydrogen as an energy storage, no matter where the energy comes from. That is, think of the possibilities of using hydrogen for electrification in any kind of mode, and especially decentralized, where you are, local production, either from water power, sun power, wind power, or the grid, as you are already connected to. That gives a lot of possibilities nowadays. If we will have this possibility to use the electricity on the grids because it's so cheap, well, that will the time show. But as far as I'm concerned, being off-grid is not always the possibility with hydrogen and fuel cells in stationary applications. Being on-grid can also be one part of build a sustainable Sweden when it comes to civil security as well. That is something that we haven't talked about today, but that is a part of it. And also every city, more or less, have capacity problems on their grids just to charge battery electric cars. Well, use the fuel cells then to power up the grids, to power up the possibilities. So I'd say that there are so many possibilities here that we haven't even looked at. So when I have on my wish list, I'd see that a hydrogen strategy for Sweden could include the companies and the initiatives like you in Gävleborg has put together here. To put that into building education, like an excellence center for this, to really look into how can the industries not only produce steel or electricity with hydrogen where they are, but how can we actually decentralize it in a smarter way? How can we use that possibility and the knowledge to decentralize energy? How do you do it to build an excellence around that and then export that to the world, because the world needs it? And the green energy that we have in Sweden, yes, so far so good, but there are days when it's not all green, and we could be totally sustainable by hydrogen production. We are not there yet. It will take time and a lot of effort, but if we put time and effort into it, we can do it.
Fantastic. What fantastic final words from Åsa there, because we have run over in time, and for that I apologize for my bad chairing, but the discussion was so interesting that I think it was worth stealing some of your lunchtime. Tahir, we've seen your question. I haven't managed to get to that one either, but maybe what we can do is follow up when we send out the presentations. If people can send them in to me and then we can distribute them. We can also try and send some information to the questions that we didn't get round to answering. But I'd like to say thank you to all of the panel, and to Paul and Lars for organising this as part of Delsbo Electric. Excellent discussion, and great to hear from the different perspectives. I've got some final comments. One thing is we have a Swedish value chain. We just need more opportunities to co-create along that value chain. I think that is a key takeaway. But we have impact, we have innovation, we have industry, we need investment, we need the infrastructure, but we can transform So those are the takeaways from this event. What goes with what? I think we've started to ask really important questions, but this will be continued. Thank you all for your
Thank you very much.
participation.
Thank you for organizing.
Sure. Very interesting. Bye-bye.
Thank you.
Thank
Bye,
you.
everyone.
Bye.
Best of luck in Delsbo. Enjoy the race.
Thanks.
Yeah.